Let's look at the solution to the JAMB Physics 2019 questions. Question 1 says, calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth is 6.4 times 10 to the power 6 meters. Take G, which is acceleration due to gravity, to be equal to 10 meter per second. This should be per second squared. So per second squared. All right. So you have options there. A, 4.2 kilometers. B, 4.0 kilometers. C, 11.3 kilometers. D, 12.3 kilometers. So how do we solve this question? Now for this question, let's write out a formula. For question 1, you're asked to calculate for escape velocity. And the formula for escape velocity is VE, right? So the E means escape, V means velocity. So VE, escape velocity, is simply equal to the square root. So it's the square root, this way here, the square root of 2 times G, acceleration due to gravity, times R, radius of the Earth. And if you do that, this is equal to the square root of, let's impute values. So have this as square root of 2 times, they said we should take G as 10, so times 10 times R. Of course, R, which is radius of the Earth, is giving us 6.4 times 10 to power raised to power 6. So we have this. So the first thing we'll do here is to work on the terms in the square root sign. All right. So what we'll do is we'll take 2, get a calculator, we'll punch 2. 2 times 10 times 6.4 times 10 to the power 6. If you punch that correctly, you have your answers 128 million. That's 128,000,000. All right. Let's take the square root of this. So the square root of 128 million. If you punch that correctly, your answer gives you 11313.7085. This would be in meters. Now the answers were given to us in kilometers. So to convert this to kilo, what do we do? So escape velocity VE is equal to, for kilo, move these 3 times to the left. So you have 1, 2, 3. That's here. So it becomes 11, this 0.3 in kilometers. So you have this. So the correct answer there is 11.3 kilometers. That is the escape velocity. The correct option there is C, 11.3 kilometers. Question 2. The distance between two successive crests of a wave is 15 centimeters and the velocity 300 meters per second. Calculate the frequency. You have option A, option B, option C, and option D. So which of these is the correct answer? Now, first things first, let's take down parameters. It said distance between two successive crests of a wave. When we say successive crest, what comes to mind is the wavelength. So they're giving you wavelength, lambda, distance between two successive crests. The value there is given as 15 in centimeters. Our task would be convert this from centimeters to meters, which means divided by 100. So 15 divided by 100. If you do that, you have your answers 0.15 in meters. We've gotten this in meters. They also said velocity V is equal to 300. The 300 is in meters per second. So you have 300 meters per second. You have to find the frequency. Frequency is unknown. So I'll use question mark there. Now let's recall the formula for this question. Recall that velocity V is equal to frequency times wavelength. And to get frequency, divide here by wavelength, divide here by wavelength. This cancels this. So frequency will be equal to the ratio of velocity to wavelength. And when you do that, velocity, the value for the velocity is, and that's equal to 300 all over 0.15. And if you punch this correctly, 300 divided by 0.15, the answer there is 2000. So I'm having 2000. We have to find frequency. Frequency is measured in hertz. So it becomes 2000 hertz. All right. Okay, so this is expressed in index form. 2000 is same thing as saying this is equal to 2 times 1000 hertz. And as we know, 1000 is 10 to the power 3. So this is simply 2 times 10 to the power 3. 1000 is 10 to the power 3. So if you bring this up, this becomes 2 times 10 to the power 3 hertz. So this is the value in index form, 2 times 10 to the power 3 hertz. So B is the correct answer. Next up, number 3 says PHCN measures its electrical energy in. PHCN is Power Holding Company of Nigeria, all right? They said it measures its electrical energy in what unit? A, kilowatt hour, B, watt hour, C, joules, D, watt. The correct answer is A, kilowatt hour, all right? Take note that PHCN, Power Holding Company of Nigeria, measures its electrical energy in kilowatt hour. That's the correct answer. Next up, question 4. 4 says, which type of motion do the wheels of a moving car undergo? A, rotational and translational motion. B, rotational and oscillatory motion. C, translational and rotational motion. D, vibratory and translational motion. So for question 4, let's consider a moving car. Question 4, let's say we have a car this way. All right, so you have a car. Let's include the wheel. So here's your first wheel, and then a second wheel. You have this. All right. Let's say this car is moving. Sorry that the first wheel is bigger than the second wheel. All right, but don't mind the diagram. Now, I assume this car is moving this way here towards the right. All right. If this car is moving towards the right, two things happen. The first thing is that this car, the wheel, all right, here's the wheel. The wheel will be rotating this way about its axis. So it undergoes rotational motion. All right, it undergoes rotational motion, also called circular motion if you want to. Now, circular motion because this wheel will be rotating this way, all right, around its axis. Again, number 2, this for this car to move towards the right, as we said, the wheel must go forward. And going forward means it is going in a straight line. And that straight line is what we call translational motion. All right, translational motion. So in essence, we can say that this wheel, that is the wheel of a moving car, undergoes both rotational as it rotates about its axis and also translational motion as it moves forward. So the correct answer there is rotational and translational, which is option C, translational and rotational motion. Question 5 says, what type of reaction is represented by the equation? You have this. So you have this 2, right? X 21x plus 21x gives you 32y plus 10n plus energy. A, fusion. B, fission. C, chain. D, ionization. So which of this is the correct answer? Let's get the major atoms here. This is your first major atom of an element. This is also the atom of the same element. And then you have this one here, the third atom. All right. What you have here is just a neutron, and then you have energy. So if you look at this correctly, you see that for this equation, you have an element here, or an atom of an element, combining with an atom of the same element, more like two atoms in the reactants part, combining to form just one atom of an element at the product part. That's if you leave out the neutron and the energy. So with this, we can say that two atoms are combining to form one atom, which this is what we know as this is what is known as fusion. All right. When we talk about fusion, we mean two things are combining to form one. All right, or two or more things are combining to form a lesser number of products. So because of this condition, we'll say number 5 is A. It's a nuclear fusion, right? It's fusion because you have elements. You can see here, you have atoms of more than one element combining to form just one atom of a product. So it's a fusion reaction. That's your correct answer. All right, number 6. Let's look at the next question. Question number 6. Question 6. A quantity that requires magnitude and direction to be specified is A. Distance, B. Displacement, C. Mass, D. Temperature. So for this question, basically, what they're asking you for is the vector quantity. When they say requires magnitude and direction, don't forget that a vector quantity is a quantity that has magnitude and direction. So which of these quantities is a vector quantity? The correct answer there is B, displacement. Okay, displacement is a vector quantity because displacement has magnitude and direction. And by displacement, we said displacement is simply distance traveled in a specified direction. Example, if a man travels 5 kilometers north, right, 5 kilometers, that's km, 5 kilometers north, what I have here is the man's displacement because I have the magnitude, which is 5 kilometers, which is the numerical value. Then I now have the direction, which is north. So the correct answer to this question is displacement. Next up, question 7. 7 says the small droplets of water that forms on the grass in early hours of the morning is A. Hail, B. Mist, C. Dew, D. Fog. For this question, the correct answer is C. Dew. All right, it's called morning dew. So dew is the correct answer. Next up, question 8. Question 8 says, when lead 210, all right, mass number 210, atomic number 82, decays to lead 206, all right, mass number 206, atomic number 80, it emits A, an alpha particle, B, one beta particle, C, one alpha and one beta particle, D, two alpha and two beta particles. Now, if I compare this PB lead 210, and then you have 82 here. Compare this to what we have as a final product, which is PB, same lead, but this is now 206, and you have here as 80. What do you observe from this one here and this? Observe that for the product here, you have 206. This particular lead or isotope of lead has lost 4 from this. All right, so you have that 210 minus 4 gives you 206. So that means you have a 4 there as a mass number. Again, looking at the atomic number, this is 82, this is 80. All right, this is 80. That means 2 is missing. So you can put 42. What we have here, 42, is simply helium. That's this. And what we have here is simply an alpha decay. All right, this is an alpha decay. Now, alpha particles are basically helium atoms. That's helium 4 and then 2 here. So for this question, it has lost just one helium, all right? Because 82 minus 2 gives you this 80, and then 240, and then 210 minus 4 gives you this 206. So it has lost just one helium or one alpha particle. That's the correct answer. So let's see which option that is. An alpha particle. The correct answer is A, an alpha particle. Question number 9 says, an object of mass 20 kilogram is released from a height of 10 meters above the ground level. The kinetic energy of the object just before it hits the ground is, you're asked to take acceleration due to gravity, g, as 10 meter per second squared. Should be a 2 here. All right. Then A is 4,000 joules, B 2,000 joules, C 500 joules, D 200 joules. So how do you solve this question? Now, just before the object hits the ground, you want to take note that the kinetic energy will be equal to the potential energy. All right. So I said this is the condition for a falling object just before it hits the ground. The kinetic energy is equal to its potential energy. From here, we can say kinetic energy, Ke, is equal to potential energy is mass times gravity times height. Let's put in value. What's the value of the mass? The mass is 20 kg, gravity is 10, and height is 10. That becomes 20 for mass times gravity, 10 meter per second squared, times height, 10 meters. If I multiply all of these, 20 times 10 gives you 2000. We are calculating for kinetic energy. Energy is in joules. So the correct answer there is 2000 joules. So for this question here, the correct answer is B, 2000 joules. All right. Finally, question 10. Question 10 says the electromotive force in the secondary winding is, so you have this. A, they said increasing, B, reducing, C, stabilizing, and D, varying. So for this question, what is the correct answer? Now, you want to know that what you have here is a transformer, and transformers operate on AC, that's alternating currents. And you want to know that an AC is constantly changing direction and magnitude. Now, therefore, we can say that the magnetic field produced is constantly changing, which means that the induced EMF, that is, the induced electromotive force in the secondary coil or secondary winding, is also constantly changing because this transformer uses an AC. So since the induced EMF or the induced electromotive force in the secondary coil is also constantly changing, we can say the value is always varying. The correct answer here is D, varying. That is the correct answer. Question 11 here says the melting point of a substance is equivalent to its A, solidification temperature, B, liquidification temperature, C, solidification pressures, D, vapor pressure. Now for this question, the correct answer there is A, solidification temperature. All right. So you want to note that the melting point of any substance is the same thing or is equivalent to its solidification temperature. So that's the correct answer. Next up, question 12. Question 12 says calculate the effective capacitance of the circuit. That's this one here. All right. Option A says 1 microfarad, B 2 microfarad, C 3 microfarad, D 4 microfarad. So how do we solve this? Now for this circuit, when it comes to finding the effective or the net capacitance, all you have to do is you calculate from the closed end to the open end. All right. This is the closed end. As you can see, here is closed, and this is the open end. This is the open end here. So you can see the gap there, right? You can see the gap there, which shows the open end. Now, having noted that from the closed end to this way, you will see that we have 2 microfarad, 2 microfarad, and then 2 microfarad. And each of these are arranged in parallel. And for capacitance in parallel, if I calculate for 1, 2, 3, these three, their effective capacitance becomes 2 here, plus 2 here, plus 2 here. 2 plus 2 is 4, plus 2 is 6. All right. So whenever you have capacitors arranged in parallel, as you can see here, parallel arrangement, just sum the figures. And when we sum them, 2 plus 2 plus 2, we now have the capacitor or the capacitance of just these three as 6 microfarad. So your new capacitance would look like this. You have something that looks like this here. Up here, this you have this one here. Down here, you already have this as 6. This is here. This is 2 microfarad. This is 6 microfarad. Then go this way. We're having this. We have this as 3 microfarad. So you have this one here, which is 3. You have this one here, 2 microfarad here. Then you have the equivalent of the other 3, 6 here. All right, so what next? The next thing you have to do here is that these three, that's 2, 6, and 3, are in series. And for capacitors in series, we have 1 all over the equivalent capacitance as equal to 1 all over the first value, 2, plus 1 all over the next value 6 plus 1 all over the next value 3. So when you have capacitors in series, just add them up. 1 all over the equivalent capacitance. This is equal to, for this we'll take the LCM. The LCM of 2, 6, and 3 is simply 6. 6 divided by 2 gives you 3. 3 times numerator, 3 times 1 gives you 3, plus 6 divided by 6 gives you 1. 1 times numerator up here, 1 times 1 gives you 1, plus 6 divided by 3 gives you 2. 2 times numerator up there, 2 times 1 gives you 2. If you work on this, this is equal to 3 plus 1 gives you 4. 4 plus 2 gives you 6. So I have this, that 1 all over the equivalent capacitance is equal to, we got numerator as 6 for the sum, all over 6. From here, you can choose to cross multiply 6 times this. That's 6 times equivalent capacitance. That becomes 6 equivalent capacitance is equal to 1 times 6 gives you 6. Divide here by 6 and then divide here by 6. This cancels this. So you have that the equivalent capacitance is equal to 6 over 6 gives you 1. So the correct answer there is 1 microfarad. So hence the equivalent capacitance is 1 microfarad. So let's see which option has 1 microfarad, and that's simply option A. So option A, 1 microfarad, is the correct answer. All right. Question number 13. 13 says, what charge is stored in a 1.0 farad capacitor when a 10 volt supply is connected across it? A, 5 coulomb, B, 4 coulomb, C, 2 coulomb, D, 1 coulomb. So how do we solve this question? For question number 19, you want to know that the charge Q is equal to the capacitance times the voltage, all right? And that's equal to, the capacitance is 0.1 farad, which is 0.1, times the voltage is 10 volts, so that becomes times 10 volts. Now multiply this, 0.1 times 10, that gives you 1 coulomb. So I have this as 1 coulomb. So for this question here, the correct answer is D, 1 coulomb. Next up, question number 14. 14 says a circuit has a resistance of 200 ohms. The resistance of the circuit can be reduced to 120 ohms when an 80 ohm resistor is connected to it in series. B, a 150 ohm resistor is connected to it in parallel. C, a 240 ohm resistor is connected to it in series. D, a 300 ohm resistor is connected to it in parallel. Now, the first thing you want to note here is that if you want to reduce the value of resistance, what you have to do is to connect another resistor in parallel. All right, that's the first you should note. So if I want to reduce the value of any resistance, for instance, reducing this from 200 ohms to 120 ohms, I have to connect another resistor to it in parallel. That means the answer is likely B because it has parallel, or D because it has parallel. If you add them in series, as you can see in A and C, it will increase the resistance, but they say reduce. So the answer cannot be A. The answer cannot be C. It's either B or D. All right. Now, with that being said, we've noted that B or D is the possible answer. The next thing you want to note is that which of this would give me 120 ohms? That's the question. Would it be connecting a 150 ohm resistor or a 300 ohm resistor? Let's try the D. Let's try using 300 ohm resistor. So we'll have that the equivalent resistance for resistors in parallel, you have 1 all over R is equal to 1 over R1 plus 1 over R2. So this is in parallel. So I have 1 all over R is equal to 1 all over R1 as given is the 200 ohms. So this is 200 plus 1 all over R2 is that resistor we are adding. All right. They said to reduce it to 120. it means the equivalent here, R, will be 120. All right. So the equivalent is 120. So what resistor value should I combine to 200 to make it 120? That's the concept there. And in solving this, move this one over here. You have 1 all over 120 minus 1 all over 200 is equal to 1 all over R2. Let's solve for R2. So in a case like this, the simplest thing we can do here, instead of stressing to get the LCM, all we can do here is do this. Now the first thing we have to do is multiply this denominator with this denominator. That becomes 120 times 200. Next up, multiply this one here with 1. That's 200 times 1, which gives you 200, minus this multiplies this 120 times 1, that gives you 120 is equal to 1 over R2. Let's work on this. Let's subtract the numerator. 200 minus 120. If I do 200 minus 120, what I have there is 80. So I have 80 all over. Next up, I have 120 times 200. If you multiply that, you have that as 24,000. You have this is equal to 1 all over R2. So at this point, we can cross multiply. 80 times R2 gives you 80 R2 is equal to 24,000 times 1 gives you 24,000. Divide here by 80. Divide here by 80. This cancels this. So R2 is equal to 24,000 divided by 80. That gives you about 300. All right. So the correct answer should be what you should connect in parallel should be 300 ohm resistor. That means the correct answer there is D, a 300 ohm resistor. All right. Next up, question number 15. It says a glass bottle of initial volume 2 times 10 to the power 4 cm cube is heated from 20 degrees Celsius to 50 degrees Celsius. Right? If the linear expansivity of glass is 9 times 10 to the power minus 6 Kelvin, it should be per Kelvin. All right? Per Kelvin, that's this. The volume of the bottle at 50 degrees Celsius is, you have option A, option B, option C, and option D. So which of this option is the correct answer? Now for this question here, this is the question on linear expansivity. So for question number 15, what do we have there? It said a glass bottle of initial volume 2 times 10 to the power 4 cm cube. Initial volume, let's call it V naught. So V naught is equal to 2 times 10 to the power 4 cm cube. This is the initial volume. What next? The next thing to observe here, they said it's heated from 20 degrees Celsius to 50 degrees Celsius. That means the change in temperature, or T1, initial temperature, is 20 degrees Celsius. T2, final temperature, is 50 degrees Celsius. So you have this. Next up, they said the linear expansivity of glass is 10 to the power minus 6. So linear expansivity is alpha for glass. Let's use G is equal to 9 times 10 to the power minus 6. Of course, per Kelvin, we have this. Okay, what else? Find the volume of the bottle at this. All right, so you have this. This, what you ask you to find is the volume or the final volume. That's what you asked to find. How do you get final volume? Recall that volume expansivity is given by gamma, and gamma is equal to change in volume all over initial volume times change in temperature. That's your formula. Now with this, we're not given the value of gamma, but we know that gamma volume expansivity is equal to 3 times alpha. That's 3 times linear expansivity. And that's simply equal to 3 into linear expansivity is 9 times 10 to the power minus 6. So we have this. So this is the volume expansivity. Let's get change in volume. For change in volume, all we have to do here, this would be equal to, of course, this is all over 1. Change in volume times 1 gives you change in volume is equal to this times this gives you gamma times initial volume times change in temperature. You have this. Again, recall that change in temperature delta T is equal to T2 minus T1, and that's equal to T2 is 50 minus in degrees Celsius minus T1, that's 20 in degrees Celsius. Subtract this, 50 minus 20 is 30 in degrees Celsius. So you have 30 degrees Celsius. We'll convert 30 degrees Celsius to Kelvin, all right? And to do that, we just add plus 273. So this becomes equal to 30 plus 273 to convert to Kelvin, and that gives you 303 Kelvin. All right. So that's the temperature. Now with this, let's impute values here. Change in volume will be equal to this value here. We said is 3 times alpha of glass, as we said earlier here. That volume expansivity is 3 times alpha linear expansivity. This times V naught initial volume times change in temperature. To have this, let's impute values. This is equal to 3 times linear expansivity of glass. We have that as this one here, 9 times 10 to the power minus 6. That is 9 times 10 to the power minus 6 times V naught initial volume. Initial volume there is 2 times 10 to the power 4. 2 times 10 to the power 4 times change in temperature. Now the change in temperature, let's see what we have here. So times the change in temperature is 303 Kelvin. So times change in temperature 303. If we multiply this, I'll just get my calculator and multiply this. That becomes 3 times 9 times 10 to the power minus 6 times 2 times 10 to the power 4 times 303. So this gives you 163.62. This is the value of the change in volume. All right. So if you ask to find the final volume will be equal to the initial volume. So final volume V will be equal to the initial volume V naught plus this one. This is in cm cube, by the way. All right. So the initial volume plus the change in volume, which is 163.62. Or let's take this as change in V. So initial plus change in volume. This value here, V naught, is what we have here, 2 times 10 to the power 4. So this is 2 times 10 to the power 4. This plus change in volume is 163.62. All right, let's get this value here. This is equal to 2 times 10 to the power 4. Simply is 20,000. 20,000 plus 163.62. This gives you 20,163.62, of course, in cm cube. All right, so this would be the final answer to this question. So let's see which option rhymes with this. So 20,000 and 20,163 point something. So the correct answer is now actually here. You'll get this answer if you do not convert this. But if you don't convert the temperature, if you use the value as 30, that's here. If you use this answer here, we had 303 here. If you use this as 30, you will get 20016, all right, which will give you this answer here. It will give you D as the correct answer. But of course, you have to convert. So for this question here, the correct answer is 2163 point, let me see, point what there? 0.62. All right, 0.62 in cm cube. This is the correct answer. All right, next up, question 16. All right, let's got the next question there. Question number 16. Question 16 says, calculate the mass of the copper, that should be of copper, deposited during electrolysis when a current of 4 amperes passes through a copper salt for 2 hours. Piece of copper Z is equal to 3.3 times 10 to the power minus 7 kilogram per Celsius. All right. You have option A, option B, option C, and option D. So how do we solve this question? Now for question number 16, for question 16, you want to note that the formula for mass deposited during electrolysis is M, and M is equal to Z times I times T. All right. Z is a value you're given in brackets here. This one, 3.3 times 10 to the power minus 7. That's 3.3 times 10 to the power minus 7. This is Z times I. So multiply this by the current times I. Let me take this one off. So multiplied by the current I. The current given in the question there is, they said 4 amperes. So 4 times the time. The time was given in 2 hours. Let's convert 2 hours to seconds. That becomes 2 times 60 times 60. All right. If you punch 2 times 60 times 60, you have your answer as 7,200. All right. This is time converted in seconds. Okay, let's multiply all of this. So if you multiply this times 4 times this, your final answer there should give you about 9.5 times 10 to the power minus 3. We're looking for mass. That would be in kilogram. So you have this. So 9.5 times 10 to the power minus 3 in kilograms. That's your value there, which is option B. So option B is your correct answer. Next up, question number 17. 17 says the focal length of a concave mirror is 2.0 cm. If an object is placed 8.0 cm from it, the image is at A, 2 meters, B, 2.3 meters, C, 2.5 meters, D, 2.7 meters. So for question 17, let's get the mirror equation. 17, let's get the mirror equation there. From the mirror formula, we have that 1 all over F is equal to 1 all over U plus 1 all over V. All right, let's impute value. You're given the focal length there as 2. So I'm having 1 over 2 is equal to, you're giving U the object distance as 8 cm, that's 8 plus 1 over V, which is the object distance, is what we don't have, and we have to look for it. To solve this question, of course, move this one over here. I'm having 1 all over 2. This moves over here, becomes negative. So minus 1 over 8 is equal to 1 over V. Let's solve this question here. This would be the LCM of 2 and 8 is 8. So I have 8 there. All right. 8 divided by 2 gives you 4. 4 times numerator, 4 times 1 gives you 4. So you have that as 4 minus 8 divided by 8 gives you 1. 1 times numerator gives you 1. So you have 1 is equal to 1 over V. Let's work on this. From here, 4 minus 1 gives you 3. So 3 over 8 is equal to 1 over V. To get V, this times this, 3 times V gives you 3V is equal to 8 times 1 gives you 8. Divide here by 3, divided by 3, this cancels this. So the image distance V is equal to 8 over 3 in centimeters. All right. If you punch this 8 over 3, let's punch this. So let's get this value in terms of decimal. All right. 8 over 3 gives you about 2.6666. So V approximately is 2.7, right, in centimeters. So this is 2.7 centimeters. So let's see which option rhymes with that. 2.7 centimeters. This should be centimeters, not meters, right? 2.7 centimeters. So you can see this is in centimeters. This is also in centimeters. So it should be in centimeters. Moving on, question number 18. 18 says, from the diagram, the region of zero acceleration is, so which of these has zero acceleration? Now, if there's acceleration, this will tilt upward, right, from left to right. This shows acceleration. All right, this is a VT graph, velocity time graph. Acceleration tilts from left to right upwards. Deceleration tilts from left to right downward. When you have this, let me draw it better. When you have this one here, this shows deceleration. All right, deceleration. And deceleration is also known as retardation. It also shows retardation. So you have this. Meanwhile, if you want to show constant acceleration, you use this. So any part that is this way or that runs horizontally like this shows constant acceleration. From the diagram, the part that shows this, the part that shows this is between N and S, as you can see from the diagram here. So the correct answer is NS. NS is option B here. Look at this. Option B, NS, is the correct answer. So that's for question 18. Let's look at question 19. Next up, question 19 says the equation P to power A, V to power B, T to power C equals constant reduces to Charles' law if you have option A, option B, option C, and option D. For question number 19, for 19 you have P to power A, V to power B, T to power C is equal to constant. Let's make this Charles' law. The first thing for Charles' law, we know that for Charles' law, you have V all over T is equal to K. So how do we transform this to V over T? The first thing you notice that for Charles' law, P is not present. So you have P. To make P disappear, we'll take this to be 0. Because P to power 0 gives you 1. And 1 times anything is that thing. So that one is gone. Again, for V, observe that V, the power of V here is 1. That means I'll be having this as 1. Then finally for T, T is a denominator. All right. If I take this out, this V over T is same thing as me saying V times 1 over T. And writing 1 over T in index form becomes T to power minus 1. So for T, the power is minus 1 is equal to K. That means if you compare them, A, which is the power of P, is 0. B, the power of V is 1. T or C, let me write this better. C, which is the power of T, is minus 1. So you have minus 1. You have 0, 1, minus 1. Let's see which option that is. 0, 1, minus 1. That is option C. Option C, 0, 1, minus 1. That's A is 0, B is 1, C is minus 1. That is your correct answer. All right, finally, question 20. Question 20 says a machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has a velocity ratio of 4. You have option A, option B, option C, and option D. Let's solve question 20. For question number 20, what do we have there? Or before then, record that the formula efficiency is equal to mechanical advantage all over velocity ratio times 100 in percentage. The efficiency here is 75%. So from here, we can say this is 75% efficiency is equal to mechanical advantage MA. Let me write this better down here. So 75% is equal to the mechanical advantage MA all over, for this question here, they gave us velocity ratio as 4. So all over 4 times 100%. First things first, percentage here cancels the 1 here. So it's gone. So I have this as 75. Let me draw this down here. So I'll have this as 75 is equal to mechanical advantage times 100 gives you 100 mechanical advantage all over 4. From here, we can get this as being 75 is equal to 100 over 4 gives you 25. That becomes 25 times mechanical advantage. So we can get mechanical advantage here by dividing here by 25, divide here by 25. This cancels this. So mechanical advantage is equal to 75 divided by 25 gives you 3. So hence we have that mechanical advantage is 3. Again, you want to recall something. Recall that mechanical advantage MA is equal to load all over effort. The mechanical advantage as we got 3 is equal to the load. The load is 1000 all over the effort. The effort is unknown. We asked to find that. To get the value of effort, of course, this is all over 1. 3 times effort gives you 3 times effort is equal to 1000 times 1 gives you 1000. You have this. Divide this by 3, divide this by 3. This cancels this. So effort is equal to 1000 divided by 3. It gives you 333.33. Effort is measured in Newton. So you have 333.33 Newton. So let's see which option that is. 333.33 Newton. That is option B. So option B is your correct answer. Question 21 says, use the diagram to answer this question. So you have this diagram here. Which of the graphs above show the characteristics of an IV? All right, IV means current voltage transistor. Option A, that's this. B, option B, that's this. C, option C, that's this. D, option D, that's this. Now, what you want to know about the characteristics of a current voltage transistor is that the first thing there is that there is rapid rise. All right. So for an IV, there's usually rapid rise, which means that the curve starts with an exponential growth and then it levels off. All right. The leveling off shows saturation. And by that, I mean for the current voltage, let's draw this. So you have current I, then you have voltage V. It starts with a rapid rise or an exponential, which is this, and then it levels off at some point, which is this. So this is what it looks like. And if you compare this to the available option, we can see that option D is the correct answer. So for 21, the correct answer there is option D. That's it. Question number 22 says, what is the equivalent of 20 Kelvin in Celsius scale? All right. You have A, minus 253.15 degrees Celsius, B, 68 degrees Celsius, C, 36 degrees Celsius, D, 20 degrees Celsius. Now, for this, you want to know that in converting from degrees Celsius to Kelvin or from Kelvin to degrees Celsius, the concept there is that the degrees Celsius value plus 273 is equal to the Kelvin value. So in this case, they give you the Kelvin value there as 20. So from here, we can say the degrees Celsius value plus 273 is equal to the Kelvin value here, as you can see, is 20. So it's equal to 20. Let's solve this particular equation there. Now, proceeding with this, we can get degrees Celsius as being equal to, all you have to do is move this one over here, and that becomes 20 minus 273. So 273. And if you do this math there, 20 minus 273, that gives you minus 253. So the degree Celsius value is actually minus 253 degree Celsius. So this becomes the answer to the question. All right, let's see which option has that minus 253. Of course, that would be A. All right, so we're going with A. A is more precise. So A is the correct answer. Next up, question number 23. 23 says, in a common emitter configuration, the output voltage is through the A, base, B, collector, C, emitter, D, resistor. Now, you want to note that in a common emitter, right, the input is through the base while the output is through the collector. In the question, you're asked for the output voltage. So the output voltage is usually through the B collector. That's the correct answer. Meanwhile, if you're asked for the input, all right, the input voltage is through the base. All right, so voltage enters through the base and leaves through the collector. So B collector is the correct answer. Next up, question number 24. 24 says a car accelerates uniformly from rest at, you have this. Now, what you're supposed to have here is 3 meters per second squared, so minus 2. Its velocity after traveling a distance of 24 meters is A, 144 meter per second, B, 72 meter per second, C, 36 meter per second, D, 12 meter per second. All right. So for 24, how do we solve 24? For 24, let's list our parameter there. The first thing you have to say, a car accelerates uniformly from rest. When a car starts from rest, we know that its initial velocity u is equal to 0. Okay. They said it accelerates. That's how I knew that this is supposed to be meter per second squared, because it said it accelerates. So you're giving acceleration there, a, as equal to 3 meter per second squared. You have this. Okay. They said its velocity after traveling a distance of 24 meters, distance s, is equal to 24 meters. Its velocity is unknown. All right, so you have this. Let's solve this question here. Now, the equation of motion that is suitable here would be v squared is equal to u squared plus 2as. All right, this is a suitable equation of motion. V squared, we don't know what v is. It's equal to, it starts from rest, so u is 0, 0 squared, plus 2 into a is 3, and s is 24. So you have this into 24. So you have this. All right, let's get this done. This becomes v squared is equal to 0 squared. This is 0, so it's off. 2 times 3 is 6. 6 times 24 gives you 144. So v will become the square root of 144. And when you do that, root 144 gives you 12. So this is 12 meter per second. So the answer there is 12 meter per second. All right, let's see which option has that. That is option D. 24, option D, 12 meter per second is the correct answer. Next up, question number 25. 25 says, what happens when three coplanar non-parallel forces are in equilibrium? A, they are represented in magnitude only. B, they are represented in magnitude in direction only. C, their lines of action meet at a point. D, their lines of actions are parallel. Now, we want to know something about the term coplanar forces. All right. For coplanar non-parallel forces, two things must happen. Number one, their resultants must be equal to 0. which is not stated here. It's not in this option. Number two, their lines of action must meet at a point. So even when they are not parallel, example, you have this one here, and then let's say a third force here. Let's add a fourth one and perhaps a fifth one. Look at this. If you look at these lines here, let's say these lines represent forces. I'll call this, let me call this F1 for force 1, F2 for force 2, F3 for force 3, F4 for force 4, F5 for force 5. Look at this, all right? These are all meeting at this point. As you can see, they are non-parallel. These lines are not parallel, but they meet at this point. That's why they are called coplanar forces. All right, so the correct answer is that their line of actions meet at the point. So hence, C is the correct answer. So C, their lines of action meet at a point, is the correct answer. Next up, question 26. 26 says, the maximum power transfer occurs in a cell when the external resistance is A, the same as the internal resistance of the cell, B, greater than the internal resistance of the cell, C, less than the internal resistance of the cell, D, twice the internal resistance of the cell. Now, you want to note that 26, you want to note that for maximum power, let's say power max, all right, for maximum power, the condition there is that the external resistance, let me call this arrow external, must be equal to the internal resistance. That's R internal. R internal. So the correct option there is that the external resistance should be equal to the internal resistance. That is the correct answer. Looking at the option there, the correct option is A, which says that the same as the internal resistance of the cell. Yes, that's correct. They must be the same or they must be equal. Next up, question number 27. 27 says the temperature at which the water vapor present in the air is just sufficient to saturate the air is A, ice point, B, saturation point, C, dew point, D, boiling point. Now for this question here, the correct answer is C, dew point. Okay, you want to note that the temperature at which water vapor just saturates air is called the dew point. So dew point is the correct answer. All right, moving on, question 28. 28 says the magnitude of the angle of dip at the equator is A, 0 degree, B, 90 degrees, C, 180 degree, D, 360 degree. For this question, the correct answer is A, 0 degree. All right. You want to note that at the equator, magnetic field lines are horizontal. Since they are horizontal, the angle of dip becomes 0. So A, 0 degrees, is the correct answer. Next up, question 29. Question 29 says, what is the best method of demagnetizing a steel bar? A steel bar magnet, okay? What is the best method of demagnetizing a steel bar magnet? A, heating it, B, rough handling it, C, solenoid method, D, hammering. Now for question number 29, the correct answer there is C, solenoid method, all right? So please note that solenoid method is the best way to demagnetize a steel bar magnet. Finally, question 30. 30 says the energy in the nucleus of atoms produce heat, which can be used to generate A, mechanical energy, B, electrical energy, C, potential energy, D, kinetic energy. So what's the answer to this question? Now, for question number 30, all right, for question 30, you want to note that usually nuclear energy is used to produce heat. All right. This heat is used to make steam. All right. And of course, this steam is used to run a turbine. This turbine is now used to produce electrical energy. So electrical energy. So from this, you can see that in nuclear power stations, what they use nuclear energy to produce usually is electrical energy. So the correct option there is electrical energy. Let's see which option that is. That is option B. So option B, electrical energy, is the correct answer. Question 31 here says, a boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. How far is he from the hill? Take the speed of sound in air as equal to 340 meter per second. A, 66 meters. B, 136 meters. C, 264 meters. D, 528 meters. So how do we solve this question? Now, this is a question on echo. Question number 31 is an echo problem. All right. And for an echo, we know that the velocity of sound, V, is always equal to 2 times the distance all over time. All right. You want to know this for an echo. Velocity is equal to 2 times distance times time. In the question there, they gave you the time there, T, as 0.8 seconds. So T is equal to 0.8 seconds. Also, they said take the velocity of sound in air, V. It's a constant. The value is 340 in meter per second. You ask how far is he from the hill? That's the distance. And to get that, let's impute value. So V is 340. We're having that 340 V is equal to 2 times D all over T. T is 0.8. So I have 0.8 here. Of course, I'll have to cross multiply. 2D times 1 gives you 2D is equal to 340 times 0.8, which is 340 multiplying 0.8. Now, working with this, we have that 2D is equal to 340 times 0.8. That gives you 272. Divide here by 2, divide here by 2. This cancels this. So D is equal to 272 divided by 2. That gives you 136 meters. All right. So the distance between the boy and the hill is 136 meters. Let's see which option that is. 136. That is option B, 136 meters. That's your answer. Next up, question 32. 32 says, in one of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the sum of the forces is A, 0, B, negative, C, positive, D, average. Now, for equilibrium, the sum of forces should be equal to 0. All right. So please take note that for equilibrium, the sum of vector forces is equal to 0. The correct answer there is A, 0. Next up, question number 33. 33 says, what is the least possible error encountered when taking measurements with a meter rule? A, 1.0 millimeters. B, 0.5 millimeter. C, 0.2 millimeter. D, 0.1 millimeter. Now, for this question, you want to note that the smallest division of a meter rule is 1 millimeter. That is the smallest division. And if you look at that, we can say that the least possible error should be equal to half the smallest division. So for 33, the smallest division of a meter rule is equal to 1 millimeter. That's 1 mm. And the least possible error should be equal to half of the smallest division. So half of 1, and that's equal to half, which in decimal is 0.5 of the unit millimeter. So the correct answer there should be 0.5 millimeters. Looking at the option there, that is option B. So option B is the correct answer. Next up, question 34. 34 says, when a negatively charged rod is brought near the cap of a charged gold leaf electroscope, which has positive charges, the leaf A collapses, B collapses and diverges again, C diverges, D remains the same. All right. Now, for this question here, you want to remember that opposite charges attract. So positive leaf would lose repulsion, which causes it to what? Collapse. So for this particular question, the correct answer there is A, collapses. All right, it will collapse. That's the correct answer. Next up, question 35. 35 says, when a telescope is in normal use, the final image is at A, the focus, B, the radius of curvature, C, the near point, D, infinity. So what's the correct answer for this particular question? Now, in normal adjustment, you want to note that final image is usually at infinity. All right, and this helps to reduce the strain on the eye. So for this question here, the correct answer is D, infinity. So note that when a telescope is in normal use, okay, the final image is usually at infinity, and this helps to reduce the strain on the eye. Next up, question 36. 36 says I, electrical potential, II, torque, III, kinetic energy, IV, momentum. Which of these quantities listed above are vectors? A, I and II, B, I and III, C, II and III, D, II and IV. All right. So which of these? Let's label 1 to 4, which are scalar and which of them are vectors. Electric potential is a scalar. So note this. Number 2, torque. Torque is actually a vector. It's a vector quantity. Kinetic energy. Kinetic energy is a scalar quantity. And then momentum. Momentum is a vector quantity. So if you're being asked which of these is a vector, II and IV, all right, they are the vectors. That's torque and momentum are the vectors. So hence the correct answer here is D, II and IV. That's the correct answer. Okay. Next up, let's get the next thing there. The next thing here is that question number 37 says the diagram shows a stationary wave of wavelength 40 centimeters in a closed tube. The length L of the resonating air column is A, 10 centimeters, B, 20 centimeters, C, 30 centimeters, D, 40 centimeters. All right. So how do we solve this question here? Now, for this question, you want to note that you're given the wavelength lambda as equal to what there? 40 centimeters, as you can see in the question here. That's wavelength. Now, for this particular question, what will be you're asked to find the length L of the resonating air column. Now, this is the air column here, and how to do that is very simple. If you look at this from this one here, you have this side here and this side, right? This side and this side forms two. You're having two movements from here. From here, you're having one, then you have this two, then you have this three. There should be a fourth one, which should be like 4 here. All right, let me do this again. Now, from this, if you observe this diagram here, the simplest way to tackle this, always remember this, that if I go this way, this is 1, and then this way, this is 2, okay, and then this way, this is 3. Now, normally, just as this part here, every part that opens this way should also end like this. So in essence, in a real sense, after 3, there should be a fourth one here that goes this way, that will end this way, like this. That would end this particular part here. So in essence, what we have here is just 3. We have just 1, 2, and 3. So that becomes 3 all over. This is supposed to be 4 in total. So it becomes 3 over 4. Now, what we'll do with this is that we'll use this to multiply the wavelength. That's how it's done. That means L will be equal to 3 over 4 times the value of the wavelength. and that's equal to 3 over 4. The wavelength is 40. L is equal to 40 divided by 4 gives you 10, right? 3 times 10 gives you 30. So I'm having this as 30 centimeters. So the correct answer here is C, 30 centimeters. That's your correct option. Next up, question number 38. 38 says, if a metal wire 4 meter long and cross-sectional area 0.8 millimeters has a resistance of 6 ohm, find the resistivity of the wire. You have option A, option B, option C, and option D. So how do you solve 38? So for question 38, let's record the formula. The resistance R is equal to rho L all over A, where rho here represents resistivity. All right. And let's list our parameters. We're giving resistance as 6 ohm. We have this. We're giving the length L as 4 meters. We have this. We're also giving the area A as equal to 0.8 millimeter square. Now, length is in meters. So we want to convert this from millimeter squared to meter squared. All you have to do is this is equal to 0.8. To convert from millimeter squared to meter squared, multiply by 10 to the power minus 6. Or you can say divide by 10 to the power 6. All right. So you're either multiplying by 10 to the power minus 6 or you're dividing by 10 to the power 6. So take note of that. All right. From here, or this is the value here in meter squared. All right. So when you do this, you've converted from millimeter squared to meter squared. 0.8 times 10 to the power minus 6. All right. So with this, we can proceed to solve this. We are asked to find resistivity rho. Let's make rho to be subject of the formula. So R is equal to rho L all over A. This is over 1. Rho L times 1 gives you rho L is equal to R times A is RA. To get the value of rho, divide here by L, divide here by L. This cancels this. So we have that resistivity, rho is equal to RA all over L. And this is equal to R is resistance. Resistance is 6 ohm. That's 6 times A. The area there is this one here in meter squared. 0.8 times 10 to the power minus 6. 0.8 times 10 to the power minus 6 all over L. L is the length, which is here as 4. So I'll have this as 4. All right, let's proceed with this. If you work on this, resistivity R or rho is equal to multiply numerator 6 times 0.8 times 10 to the power minus 6 gives you 4.8 times 10 to the power minus 6 all over denominator is 4. So you get your calculator and punch this. Punch 4.8 times 10 to the power minus 6 divided by 4. You have your final answer as 1.2 times 10 to the power minus 6. Resistivity is in ohm meter. So ohm meter, you have this. So this becomes the correct answer to this question. So let's see which option has this particular answer. 1.2 times 10 to the power minus 6 ohm meter. That is option B. So option B is the correct answer. All right, next up, question number 39. 39 says, from the diagram, the point that represents the elastic limit is, so here's a diagram here, load against extension. Which of these points, Q, R, S, T, represents the elastic limit? A, Q, B, R, C, S, D, T. From here, you can see that the elastic limit is at this point here, all right, this point here, which is B, that's R. All right, so this is the elastic limit. All right, then from here to here is your plastic limit, or S is the plastic limit. Meanwhile, here's where it becomes plastic. So that's your plastic region. That's where it has lost its elasticity. Then from S to T is the breaking point. This is where it breaks. All right. breaking. So if they ask for elastic limit, it's at this point here, which is R, and that is option B, R. Finally, question number 40. 40 says, which gas produces a pink color light in a discharge tube? A. Argon. B. Air. C. Neon. D. Mercury. Now, for this question here, you want to note that the gas that produces a pink colored light in a discharge tube is actually neon. All right, so neon is the correct answer. Okay, so note that neon gas glows pink or sometimes red in a discharge tube. So neon becomes the correct answer to this question. Okay. Question 41 says, the quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's A. Internal energy, B. Specific heat capacity, C. Specific heat capacity, D. Heat capacity. For this question, the correct answer there is D, heat capacity. All right. So you want to note that the quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's heat capacity. Now, note that if they had said the quantity of heat needed to raise the temperature of a body by 1 Kelvin per unit mass, all right, if they mention per unit mass, then the answer would have been specific heat capacity, all right. When you hear per unit mass, it becomes specific heat capacity. But since they did not mention per unit mass here, the answer becomes heat capacity. Question 42. An object is placed 10 meters from a pinhole camera of length 25 centimeters. What calculate the linear magnification? You have option A, option B, option C, and option D. So how do you solve this question? For question number 42, they said an object is placed at 10 meters. All right, so let's write down the given parameter. In the question there, the object distance u is equal to 10 meters because the object is placed at this distance. And they said the length of the pinhole camera. You want to take note that the length of the pinhole camera is the same thing as the image distance, v, right? And for this question here, the value of v was given as 25 centimeters. So you have this. We are asked to find magnification. Magnification m is equal to image distance all over object distance. And that's equal to image distance is 25 all over the object distance. I'll have to convert to centimeters. That means 10 meters. We convert to centimeters. That becomes 10 times 100. Right? So multiply the meters by 100 to get centimeters, and that becomes 1000 centimeters. Now use centimeter values here. It becomes 25 over 1000, right? And if you punch 25 over 1000, your value is simply 0.025 in centimeters. Sorry, 0.025. Magnification does not have an SI unit, all right? And that's equal to, write this in index form. This becomes 2.5. From here, you have 1, 2 times 10 to the power minus 2. All right, no SI units. Okay, so let's check which option has this value. 2.5 times 10 to the power minus 2. That is option A. So option A is the correct answer. Next up, question 43 says, heat transfer by convection in a liquid is due to the A. Increased vibration of the molecules of the liquid about their mean position. B. Variation of density of the liquid. C. Expansion of the liquid as it is heated. D. Latent heat of vaporization of the liquid. So what is the correct answer for this question here? For this question, the correct answer is B, the variation of density of the liquid. Now, here's something you need to know. When it comes to convection, convection in liquids happen because warm liquid become less dense and hence rises while cold liquid sinks. So due to this difference in the density of hot liquid and or warm liquid and colder liquid, the convection seems to take place. All right. So we can say that it is due to the difference in the density of warmer liquids and colder liquids that convection takes place. Hence, we can say the variation of densities of the liquid causes heat transfer by convection. So B, variation of density of the liquid, is the correct answer. All right, next up, question number 44. 44 says, when an atom undergoes a beta decay, the atomic number of the nucleus A decreases by 1, B increases by 1, C becomes 0, D remains unchanged. Now let's look at this. For 44, you have an atom of an element X with atomic number A and mass number Z. If this atom emits a beta decay, so I'm taking off, right? So emit, it's losing. So lose a beta decay. Usually, beta decays are almost the same thing as electrons, all right? So we can say beta decay or beta particles are equivalent to electrons. So it loses, so minus an electron. An electron is E minus 1 here and then 0. Now, what's your final result here? Your final result here is that you have the same atom here, X. You have Z minus 0. Of course, anything minus 0 is that thing there, so it becomes Z. Again, here you have A, that's A, minus minus. Minus minus gives you plus, so it becomes A plus 1. So you have this. Now, the difference here is that if you observe here, the mass number is the same thing. Meanwhile, the atomic number has now been increased by 1. So the answer there for 44 is that the atomic number increases by 1. So what they said, the atomic number of the nucleus, what happens? The answer is B, increases by 1. So 44, B is the correct answer. Next up, 45. 45 says, in a compound microscope, the objective and the eyepiece focal lengths are A, long, B, short, C, the same, D, at infinity. So what is the correct answer for this question? For this question, note that in a compound microscope, the objective lens is the objective lens has a very short focal length, and the eyepiece lens also has a very short focal length. So therefore, the focal length of the objective lens and the eyepiece lens are both short. So for this question there, the correct answer is short. All right, that's the correct answer. Next up, let's look at question 46. Question 46 says the diagram is that of, so you have this diagram here. A step up transformer, B, a step down transformer, C, an auto transformer, D, an oil transformer. All right. So how do we know from this diagram here? Now, here's what to observe. If you look at this diagram here, you'll see that, look at the input parts. We can say that the input coil, look at the coil at the inputs there. The input coil has fewer turns. Look at this. Look at this. The turns of the input coil is fewer. Meanwhile, look at the output coil. Look at the output part. For this output part, we can say that the output coil has more turns. In essence, from this diagram here, the input coil has fewer turns while the output coil has more turns. All right. Now, more turns on output causes a voltage increase, and a voltage increase results in what is called a step up transformer. All right. So for this question here, the correct answer is a step up transformer. And that's because you have more turns at the output coil than the input coil. Because more turns at the output coil causes a voltage increase. And that's for a step up transformer. So A is the correct answer. All right. Next up, question number 47. For 47 there, it says an object of weight 80 kilogram on Earth is taken to a planet where the acceleration due to gravity is one-third of its value on Earth. The weight of the object on the planet is, you have, take acceleration due to gravity as 10 meter per second squared. This would be per second squared. That's this. Option A, 12 Newton. Option B, 27 Newton. Option C, 37 Newton. Option D, 48 Newton. Now let's write up parameters here. In this case, you're given, said, an object of weight 80 kilogram. All right. So the what you're actually given here is not the weight but the mass. All right. So the mass is 80 kilogram. They gave you G, acceleration due to gravity. Of course, this is on Earth at 10 meter per second squared. So let's solve question 47. 47, listing out parameters, we are given the mass, although they mention weight, but what you have here is actually mass. You're given the mass of that object as 80 kilogram. You're given G, acceleration due to gravity, as 10 meters per second squared. Right? Now, what is the weight? From this question here, you ask to find the weight of the object on the other planet. Now, for the other planet, let's get the acceleration due to gravity on that planet. We'll call it G planet. All right. The acceleration due to gravity on that planet, G planet, is equal to, they said, is one-third that of the Earth. That becomes 1/3 times the gravity of the Earth. And that's equal to 1/3 times the gravity of the Earth is 10. So if you multiply this is equal to 10/3 in meter per second squared. All right. So since the acceleration due to gravity of the planet is one-third of that of the Earth, that becomes 10/3 in value. So we have this. Now we are asked to find its new weight in the planet. So let's call that the new weight. The new weight, W, will be equal to, we know that weight is mass times gravity, all right? Now, mass is constant, it does not change. Hence, for the gravity, there we use the gravity on that planet, all right? So mass times the acceleration due to gravity on that planet. And that's equal to, the mass is 80, all right? So mass is 80 times the gravity of the planet is 10/3. If you multiply this, the first thing you have here is 80 times 10. 80 times 10 gives you 800. Now 800 divided by 3, so 800/3. If you punch 800/3, your value there is 266. So this will give you 266.67. We are measuring weight, all right? We are calculating for weight. Weight is in Newton. So you have 266.67 Newton. That will be the value. So you can see none of the options are here. All right, so let's see. So the correct answer should be 266.67 Newton. That should be the correct weight. All right. All right, moving on. Question number 48. Let's do 48. 48 says a force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 meters. The tensile stress is, you have option A, option B, option C, and option D. So how do we solve this question? Now, for question number 48, you want to take that stress is equal to force all over area, all right? By definition, it's simply the force acting per unit area. So stress is equal to force over area. From the question there, the value of the force is 500 Newton. So 500 Newton all over. The area is 0.2. That should be meter squared. So 500 divided by 0.2. I'll get my calculator and punch 500 divided by 0.2. That gives you 2,500. 2,500 Newton per meter squared. Put this in index form. This is equal to 2.5 times 10 to power 3. This will give you 2,500 in Newton per meters squared. So here's my correct answer, 2.5 times 10 to the power 3. And that is option C. So option C is the correct answer. Next up, question 49. 49 says a wheel and axle is used to raise a load whose weight is 800 Newton when an effort of 250 Newton is applied. If the radii of the wheel and the axle are 800 millimeters and 200 millimeters respectively, the efficiency of the machine. So they're asking you for efficiency here. A, 80%, B, 85%, C, 87%, D, 90%. All right. So how do we solve this particular question? What do we do? Now, for this question here, you're given the load, right, as 800 Newton. You're given the effort as 250 Newton. You're given the radius. The radius of the wheel is 800 millimeters, and the radius of the axle is 200 millimeters. You have to find efficiency of the machine. Now for 49, you want to note that efficiency, okay, let me write the efficiency is equal to MA, mechanical advantage, all over VR, velocity ratio, times 100 then percent. That's your formula. For the mechanical advantage, MA, mechanical advantage is simply ratio of load to effort, load all over effort, and that's equal to, for the load, the value is 800 Newton, so 800 Newton load all over, for the effort, the value there is 250 Newton, so 250 Newton. Let's work on this. That becomes 800 divided by 250, and that's about 3.2. All right, so mechanical advantage, that means MA, mechanical advantage is equal to 3.2. It does not come with an SI unit because here Newton cancels with Newton, no SI units. So this is the mechanical advantage. Let's get velocity ratio. Velocity ratio is equal to, for this particular question, all right, look at the question that they said for wheel and axle. Now, for wheel and axle, note that velocity ratio is equal to the radius of the wheel all over the radius of the axle. All right. Radius of the wheel in the question is given by 800 all over. Radius of the axle is 200. So if you punch 800 over 200, your value gives you 4. Now with this, we can find efficiency. So we can finally say that efficiency rho is equal to mechanical advantage 3.2 all over velocity ratio 4 times 100%. And that's equal to, so punch 3.2 all over 4, and that's about 0.8. 0.8 multiplied by 100, you add the percent there. That's equal to 0.8 times 100, and that's giving you 80. So 80, you add the percentage, 80%. So from this question there, the efficiency is 80%. Let's see which option has 80%. That is option A. So option A, 80%, is the correct answer. Next up, question 50. 50 says a Zener diode is used for A, current amplification, B, power amplification, C, voltage regulation, D, energy conversion. So for this question, what is the correct answer? Now, for this question here, you want to note that a Zener diode is used for voltage regulation. So the correct answer there is C. All right. The function of a Zener diode is to keep the voltage constant. All right. And if it has to keep the voltage constant, that means it is regulating the voltage. So hence, the correct answer is C, voltage regulation. All right, guys. So we've come to the end of the JAMB Physics 2019 exam questions and solution. Don't forget to like this video and also subscribe to this channel for updates on JAMB Physics, JAMB Chemistry, JAMB Mathematics, and JAMB Biology. All right. If you're yet to join our JAMB WhatsApp group, there's a link to join our JAMB WhatsApp group in the video description. You can also get exclusive content by joining our JAMB channel membership. Okay, guys, so please take note that we have a JAMB WhatsApp group for JAMB Bytes. All right. So if you're writing JAMB, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bytes, or you can get the full JAMB course on our website. Simply visit www.jonahemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.